In 1982, a geologist named Christopher Scotese sat down with decades of plate tectonic data and did something almost nobody had seriously attempted before. He ran the clock forward instead of backward. Scientists had spent over a century reconstructing Pangea, the ancient supercontinent that broke apart roughly 200 million years ago. But Scotese flipped the entire model, using the measured drift speeds of Earth's tectonic plates, only inches per year, to project exactly where those same continents would end up in the far future. What he produced sent a quiet shockwave through the geological community. A detailed map showing the continents slowly reassembling into a brand new supercontinent, one he named Pangea Proxima, expected to fully form roughly 250 million years from now. It was the first serious scientific proof that Earth is not a finished, static object frozen at its current shape. It is a planet still actively rearranging itself beneath our feet, 1 inch at a time, and that process will not stop just because human civilization eventually does. That single projection is the perfect place to start, because it forces us to confront an uncomfortable truth. The Earth beneath your feet right now is temporary. The oceans, the continents, the climate, even the length of a single day, all of it is quietly shifting. And if you could fast forward far enough into the future, you would not recognize this planet at all. So today we are traveling forward in time. First, just 10,000 years, then further and further, all the way out to 1 billion years from now, watching civilizations, languages, coastlines, and entire ecosystems transform beyond recognition. And once we've gone as far forward in time as the human mind can reasonably process, we are going to ask an entirely different kind of question. What would happen if Earth itself were relocated, not through time, but through space, dropped directly into the center of our own galaxy, into one of the most violent and radiation-soaked regions in the entire Milky Way? By the end of this, you will understand exactly how fragile our comfortable, stable version of Earth actually is, and just how many everyday facts you already believe turn out to be complete myths. Let's get into it. Earth itself is about 4.5 billion years old, and when it first formed, it looked absolutely nothing like the planet we know today. It was an extremely hot world, essentially drowning in molten magma from surface to core. Over the following few hundred million years, the planet gradually began to cool, and that is when liquid water finally appeared on its surface, forming the very first oceans. During this same cooling period, heavier elements that had been floating near the surface began sinking down through the magma and water toward the planet's center, while lighter materials rose toward the top, and that is how Earth became layered, a solid outer covering of relatively light material wrapped around a dense, heavy core. That is how it all began roughly 4.5 billion years ago. Now, speaking of such a distant future, 1 billion years forward is genuinely no small leap, and the honest truth is that the odds of humanity still existing by then are extremely slim. There are simply too many potential threats standing between now and then: climate change, overpopulation, falling asteroids and comets, recurring ice ages, and the slow, inevitable brightening of the sun itself. But let's imagine, just for the sake of this journey, that you somehow got your hands on a working time machine and you decided to make a series of stops along the way to watch Earth's future unfold in real time. Your first stop is just 10,000 years into the future. One of the most immediately noticeable changes is in the people themselves. Genetic differences that once mapped neatly onto specific regions of the world have gradually spread and blended, meaning traits like skin tone, hair color, and eye color are now distributed far more evenly across the entire global population, rather than clustering by geography, the way they historically did. Jump forward another 10,000 years to 20,000 years from now, and something even stranger has happened. You genuinely cannot understand anyone around you anymore. None of today's languages remain recognizable in any meaningful way, and the vocabulary people actually use in daily conversation retains only about 1% of what exists in modern human languages today. Push forward again to 50,000 years into the future, and you step out of your time machine directly into a new ice age. Niagara Falls, one of the most famous waterfalls on the planet, has eroded dramatically from its current position, reshaped almost beyond recognition by the sheer volume of water passing over it across tens of thousands of years. And remarkably, a single day on Earth has grown by a full second compared to today, a direct consequence of the moon's slow, ongoing gravitational tug gradually breaking our planet's rotation. Your next stop lands you 250,000 years into the future. And the landscape has shifted again, this time with an entirely new island having formed near Hawaii, the natural result of ongoing volcanic activity, continuously building new land along that stretch of the Pacific. But when you step out of your time machine 500,000 years into the future, you immediately realize something has gone catastrophically wrong. Fires are raging across huge stretches of the planet, and the air itself is barely breathable. The cause becomes clear almost immediately: a massive asteroid that humanity, in this particular timeline, failed to detect or deflect in time. You climb back into your time machine and set the dial for 1 million years into the future, hoping for better luck. But this time it's a different kind of disaster altogether. A colossal supervolcano eruption has just occurred, spewing hundreds of cubic miles of ash into the atmosphere, already producing enough accumulated lava to fill roughly 75% of the entire volume of the Grand Canyon. By the time you reach 2 million years into the future, humanity has finally spread meaningfully beyond Earth itself, establishing permanent settlements scattered across the wider solar system. Remarkably, humans living on different planets and moons now look noticeably different from one another, their bodies having gradually adapted to the specific gravitational, atmospheric, and radiation conditions unique to each world they've settled. Fast forward to 50 million years from now, and Earth itself is still actively reshaping. A massive section of eastern Africa has fully separated from the rest of the continent, carving out an entirely new ocean basin in the process, while at the same time, the African continental plate has collided directly with Eurasia, sealing off the Mediterranean Sea entirely and thrusting up a brand new mountain range between the two landmasses, one that towers even higher than Mount Everest does today. Meanwhile, out in our own solar system, Mars has collided with one of its own moons, and the resulting debris has settled into a striking new ring system encircling the planet, not unlike the rings that currently make Saturn so instantly recognizable. Pushing much further forward, to 600 million years into the future, you arrive just after a massive gamma-ray burst has erupted from a source roughly 6,500 light-years away from Earth. Fortunately, in this particular timeline, the burst's deadly radiation missed our planet entirely because, had it struck directly, it likely would have stripped away Earth's protective ozone layer completely, almost certainly triggering a mass extinction event on a scale rivaling anything in the planet's geological history. You also notice that something else has quietly changed. The moon has drifted so far from Earth by this point that total solar eclipses, events that have fascinated humanity for its entire recorded history, are no longer physically possible at all. The moon has simply become too small in our sky to fully block the sun's disk anymore. And now, finally, your last stop, Earth exactly 1 billion years from now. You step out of the time machine and freeze, genuinely in shock, because the once vibrant blue and green planet you knew has become an almost completely lifeless desert. Atmospheric carbon dioxide levels have collapsed so severely that photosynthesis is no longer possible anywhere on the planet's surface, which means the free oxygen and protective ozone that once defined Earth's atmosphere have vanished entirely, and along with them, every trace of complex life. On top of that, the sun's overall luminosity has increased by roughly 10% compared to today, an entirely natural consequence of stellar aging, but one with devastating effects, pushing average surface temperatures on Earth to at least double what they are now. Standing there, it genuinely feels like you're trapped inside some enormous humid greenhouse. The planet's oceans, once covering the majority of Earth's surface, have almost completely evaporated, leaving behind only a handful of small, shrinking pools of water clinging to the polar regions. As for humanity itself, you won't find a single person anywhere on Earth by this point, because by now, whatever remains of the human species has long since relocated to distant planets and even distant galaxies far beyond our own, having abandoned this increasingly inhospitable version of Earth many generations earlier. At this point, honestly, you should probably climb back into your time machine and leave too, because this particular version of our home planet clearly has nothing left to offer. Now, let's shift gears entirely and travel not through time but through space, straight into one of the most extreme and violent environments the galaxy has to offer, the center of the Milky Way itself. The heart of our galaxy is a place defined by intense radiation, crushing gravity, and genuine cosmic mystery, an environment where the ordinary forces of nature are pushed to their absolute physical limits. But what would actually happen if Earth itself were somehow relocated directly into this cosmic theater and, against all odds, somehow managed to survive the trip? Let's find out. Picture yourself floating in open space, surrounded on every side by billions upon billions of stars, when suddenly, off in the distance, you spot a massive, swirling mass of gas and dust, our home, the Milky Way galaxy. Astronomers estimate the Milky Way contains over 100 billion individual stars, and stretches roughly 100,000 light-years from one edge to the other, meaning that even traveling at the literal speed of light, it would take a full 100,000 years just to cross from one side of our galaxy to the other, a distance measured in the trillions of miles. And it is far from static. The entire Milky Way is currently hurtling through the wider universe at a staggering speed of roughly 1.3 million miles per hour. One of the most striking things about our galaxy is its overall shape. The Milky Way is classified as a spiral galaxy, meaning it takes the general form of a flattened disk with a dense central bulge and sweeping spiral arms extending outward from it. Those spiral arms are where new stars are actively being born, since they contain the highest concentrations of gas, dust, and stellar material anywhere in the galaxy. And it happens to be inside one of those arms where our own solar system is located. In the grand scheme of the Milky Way, our entire solar system amounts to little more than a tiny speck, sitting roughly 26,000 light-years away from the galactic center, a genuinely enormous distance by any measure. Our solar system is also constantly in motion, slowly orbiting the center of the galaxy as a whole, and it takes approximately 230 million years to complete just one full orbit. To put that into perspective, since the age of the dinosaurs, our entire solar system has only traveled about a quarter of the way around that single orbital path. Our specific location within the galaxy actually shapes daily life on Earth in ways most people never consider, influencing everything from the amount of background radiation and cosmic rays we're regularly exposed to, all the way down to the statistical likelihood of asteroid impacts over long stretches of time. And thanks to exactly where we happen to sit within the Milky Way, we're treated to genuinely breathtaking views of the wider universe, distant galaxies, glowing nebulae, and dense star clusters, all visible in remarkable detail from our relatively quiet, stable corner of the galaxy. In short, in terms of galactic real estate, we got remarkably lucky. But what if we hadn't been so lucky? What if Earth were instead located directly at the center of the Milky Way? That central region is home to something astronomers call the central bulge, an area absolutely packed with stars, roughly 10,000 light-years across, essentially functioning like a massive cosmic disco ball, except instead of shiny mirrored panels, every single reflective surface is an actual star. The galactic center is also home to some of the most extreme physical conditions imaginable, conditions that would make even the most seasoned astronaut nervous. High-energy particles and intense magnetic fields there are powerful enough to wreak havoc on sensitive electronics and spacecraft systems, while intense radiation fields are strong enough to effectively fry almost anything caught directly in their path. In short, it is not exactly a hospitable environment for life as we currently understand it, so if Earth genuinely were relocated somewhere closer to that galactic center, life here would look drastically different. Assuming any life could survive there at all, let's break down a few of the most significant effects one at a time. First, radiation. As already mentioned, the galactic center ranks among the single most radiation-dense regions anywhere in the entire Milky Way, a condition that would make sustaining life on Earth extraordinarily difficult, if not flatly impossible. Sure, Earth currently has its own magnetic field, functioning essentially like a giant protective shield, deflecting the majority of harmful radiation arriving from deep space before it can reach the surface. But could that same magnetic shield realistically hold up against radiation levels found at the galactic center? Unfortunately, the honest answer is almost certainly not. It would be roughly equivalent to holding up a small umbrella against the full force of a massive hurricane, completely overwhelmed almost instantly. That said, it's not entirely a lost cause. Certain remarkably resilient organisms here on Earth have already demonstrated a genuine ability to adapt to unusually high radiation levels, and we already know life on this planet has managed to evolve and survive in some genuinely extreme environments, from the crushing depths of the deep ocean to the frozen isolation of the polar ice caps. So let's imagine, purely hypothetically, that some form of life on this radiation-soaked version of Earth somehow managed to evolve accordingly. Picture humans with tough, scaly skin specifically adapted to block harmful radiation, or plants that develop entirely unique structural adaptations, allowing them to thrive under such intense, radiation-heavy conditions. Even so, that constant radiation exposure would likely produce some genuinely strange, almost unsettling side effects over time. It could easily damage DNA at the molecular level, triggering widespread mutations across generations. Imagine an entire ecosystem where plants routinely grow 5 leaves instead of the usual 4, where animals develop strangely colored fur unlike anything we currently recognize, or where people are born with genuinely unique, unusual eye colors and other distinctive physical traits. And those examples honestly represent some of the more benign possibilities worth mentioning. Beyond direct genetic mutation, that intense radiation exposure could also drive broader metabolic changes across entire species. It's entirely plausible that organisms living under those conditions might process food and other biological resources considerably faster than they do today, potentially resulting in noticeably accelerated growth rates and significantly larger overall body sizes. Plants in that environment might grow unusually tall and thick, while animals could end up substantially larger than anything currently found on Earth. There are also certain organisms here on Earth today capable of bioluminescence, essentially producing their own light through natural biological processes, largely thanks to specific chemical reactions, some of which are influenced by radiation exposure. Under the heightened radiation levels found at the galactic center, these organisms could potentially glow even more intensely than their current counterparts. Picture walking through a dense forest at night and finding the trees, mushrooms, and even individual insects around you, softly glowing with an eerie blue or green light, something genuinely equal parts frightening and strangely beautiful. But radiation is far from the only major concern in this hypothetical scenario. There's also the matter of gravity. The gravitational forces at the center of the Milky Way are extraordinarily strong, driven primarily by the presence of a supermassive black hole roughly 4 million times the mass of our own Sun, known to astronomers as Sagittarius A star, our theoretical and thoroughly terrifying new galactic neighbor. Assuming, purely hypothetically, that Earth somehow avoided being swallowed whole by that black hole or crushed outright by its immense gravitational pull, that gravity alone would still be more than capable of triggering constant, widespread earthquakes and volcanic eruptions across the entire planet. Essentially, that supermassive black hole would function like an enormous gravitational bully, relentlessly tugging and pulling at absolutely everything within its reach. If humanity somehow managed to survive under those conditions, life would essentially become one continuous, terrifying natural disaster. And forget about easily escaping the planet either. Launching rockets successfully under gravitational stress that extreme would become dramatically more difficult, if not outright impossible, using anything resembling current propulsion technology. And it's not just physical objects that would be affected by gravity this intense. Time itself would behave noticeably differently for anyone living there. According to Einstein's theory of relativity, time passes measurably more slowly in regions, experiencing significantly stronger gravitational fields. In practical terms, that means people living on this hypothetical galactic center version of Earth would effectively age more slowly compared to someone living farther away from the galaxy's gravitational core. On top of that, the galactic center is an extraordinarily busy region of space, packed with stars, planets, and other celestial bodies, constantly moving at incredibly high relative speeds. The positions of nearby stars and other objects in the sky would be shifting constantly and noticeably, meaning conventional navigation as we currently understand it would become essentially useless. Any kind of GPS-style positioning system would likely become completely unreliable, overwhelmed by both the intense surrounding radiation and the constantly shifting gravitational forces at play. So if you somehow found yourself lost inside a glowing, radiation-soaked forest surrounded by unfamiliar, mutated wildlife under these conditions, you would genuinely be on your own. That said, it's not entirely bad news even in this extreme scenario. The galactic center also happens to be home to massive molecular clouds, regions of space specifically responsible for actively forming brand new stars. And the wider Milky Way galaxy already offers some genuinely spectacular cosmic sights, even from our current, much safer vantage point. Stunning, glowing nebulae like the Orion Nebula and the Eagle Nebula, both clearly visible using nothing more than a decent telescope, or in some cases, even a good pair of binoculars. So if Earth truly were relocated to the galactic center, we would technically have an absolutely front row seat to some of the most visually spectacular cosmic phenomena imaginable, which, in its own strange way, would honestly be pretty incredible to witness. Overall, though, if Earth genuinely were located at the center of the Milky Way, it would be an almost unrecognizably different place from the planet we currently call home. Of course, realistically, our planet almost certainly would not have survived such a dramatic relocation in any recognizable form at all, but it remains a genuinely fascinating thought experiment to imagine how radically different life here would look under those extreme conditions. All of which is really just one more reason to appreciate exactly how quiet, stable, and comparatively peaceful our actual little corner of the solar system genuinely is. Now, before we wrap up entirely, let's clear up a handful of surprisingly persistent myths that tend to circulate specifically around space, earth science, and the natural world, several of which are almost certainly things you believed your entire life without ever questioning them. Let's start with something that sounds strange but is entirely accurate. There is no such thing as a permanent dark side of the moon. Our natural satellite is tidally locked with Earth, meaning we only ever see one hemisphere of it from the ground, but the sun itself follows no such restriction, and shines directly on every side of the moon in turn, exactly as it does on everything else in the solar system. This is also precisely why solar eclipses are even possible in the first place. Since the far side of the moon absolutely does receive sunlight, it's specifically the moon passing directly between Earth and the sun that temporarily blocks that light from reaching us. Interestingly, solar eclipses happen to work out so precisely because the sun sits roughly 400 times farther from Earth than the moon does, but is also coincidentally about 400 times larger in actual size, meaning the two objects appear almost exactly the same size in our sky, producing that dramatic, complete blocking effect topped off with nothing but a faint, glowing ring of light around the edges. Here's another myth worth addressing directly. Our planet Earth is not actually a perfect sphere, though calling it simply elliptical wouldn't be technically accurate either. Scientists actually use a specific term for Earth's true shape, called a geoid. Earth's constant rapid rotation causes it to bulge very slightly outward, making it subtly elongated rather than perfectly round, but that's not the only factor at play. The tectonic plates constantly shifting beneath the surface, even though that movement happens at a painfully slow pace of only a couple of inches per year, also gradually affect the planet's overall shape over time, causing certain regions of the surface to rise while others gradually sink or dip downward. Given enough time, this ongoing process means Earth's true shape more closely resembles a slightly misshapen balloon than any perfectly clean geometric sphere. And one final surprising fact worth clearing up: contrary to popular belief, bats are not actually blind, and that particular myth almost certainly comes from the fact that bats primarily rely on echolocation, using sound waves rather than eyesight, to navigate effectively in complete darkness. In reality, a bat's eyesight is actually considerably better in low light or nighttime conditions than typical human vision, though bats do perceive their surroundings largely in shades of black and white rather than full color, which is exactly why they tend to become noticeably disoriented, specifically in bright daylight conditions. Not because they're blind, but because their eyes are genuinely optimized for an entirely different lighting environment than the one most of us navigate through every single day. So from continents silently drifting apart over hundreds of millions of years, to oceans slowly evaporating a billion years from now, to the sheer humbling scale of our own galaxy, stretching 100,000 light years from edge to edge, one thing becomes remarkably clear: the version of Earth we call home right now is nothing more than a single, brief, comfortable snapshot in an extraordinarily long and violent cosmic story, and we happen to be here to witness it during one of its calmest, quietest chapters.